All right. Back to this. Next page, as I said, I'm going to start with the second problem rather than the first one. Note that in this one, we are going backwards. Instead of having an equation, we're going to graph it. We have the graph and we want to actually write the equation for it. And just like last time, I usually start with the whole restrictions of what's going on, and then we'll find the lines over there. So it's important to look at how many boundaries there are. Like most people want to say, where are the boundaries? This one's pretty obvious. Right here is going to be one of the special places where part of it exists and part of it doesn't. As it turns out, there's actually two more, and that comes from the fact that there are no arrows. If there was an arrow going over here, then you could just have, x is less than 1, x is greater than 1 to separate it. But because it ends here, you also have to create a boundary on each of those. So there's this line between -4 and 1, and then there's this line between 1 and 3. And there's actually a way you write that in math. Really, here's just the -4, here's the 1, those are the boundaries. The way you're going to write it as an inequality is you're going to put an x between them, and then you're going to use less than symbols. Sometimes less than equal to, but always less than. That is because on this side, x is less than 1. As you can see, it's less than 1. And if you look at over here, x is more than -4. So -4, x is more than it. So it's always got to be less thans like that. In this case, if you look at it, that is solid and that is solid, which means these less thans are both also going to be equal to's. So over here, I'm going to write that down. -4 less than or equal to x is less than 1. And make sure you are leaving space right there for us to write our equation later. For the next part, right here, this is 1 and that is 3, and something very similar is going to happen. The x is going to be between them, and it is always less than. Here it's an open circle, so it is not equal to. This is a closed circle, so it is equal to. And we'll write that one over there. 1 is less than x is less than or equal to 3. There we go. The next part is actually writing the equation of the line. The first one's a bit easier because when you're looking for slope-intercept form, you want the slope and you want the intercept. And you can actually see the intercept right there. It's at 1. We are going to be putting these into y equals mx plus b form, where, if you have forgotten, m is the slope and b is the y-intercept. So in this case, the y-intercept is 1. And slope you can just count. It's rise over run. So if you're at this point, you're going to that one. You're rising 1, running 1. So it's 1 over 1. So 1 over 1x. But, 1 over 1 is just 1, and 1 times x is just x. So you end up just getting x plus 1. And that's the equation of the line. Plus 1 means you start at 1. Slope of 1 means up 1 over 1. So it all checks out. For the next one, this one is not as easy to see where the slope-intercept form is going to be because it doesn't have a y-intercept right now. And this is probably the biggest problem I have students do. Please do not say the intercept is -1 because it's not. That's where the boundary is. This is the y-axis. This is where it needs to be crossing. You have to imagine that it was to extend. And if it extended, then what would its intercept be? So if you extended, this is where it's hitting the y-axis at 0, which means the y-intercept is 0. So when you do y equals mx plus b, b is 0. And the slope in this case is down 1 over 1, down 1 over 1, down 1 over 1. So -1 over 1. Or just -x plus 0 is nothing. So y equals -x. Sorry about that. Motion sensor lights. Yeah. So you write negative x. And that's the entire answer to this question. In terms of domain and range, once again, there is no arrows. Because there's no arrows, you will not have infinities for the domain. The furthest left it gets is right here at -4. And if you travel along, you have a solid dot, which means you're A-OK at this point, and you continue on until you get to 3. You don't need a union because these match up. And these will both be brackets because they are both solid. For range, the lowest it gets is here at -3. It doesn't matter which -3 you're talking about because it's both -3. When it comes to the tallest it gets here is 2, and it's everything in between. Everything in between. Please note that you don't have to worry about this space over here. They kind of just overlap each other. This covers everything. This is already taken care of. Everything between -1 and 3 is already here between -1 and 3, right? It's already filled in, so you don't have to write it again. Any space that's blank right here, it's filled in right there. Everything between -3 and 2 works, so you don't have to worry about that. All right. Going back up to this one, it's pretty similar in terms of the boundaries. There's a lot of boundaries here. There's one there, there's one there, there's one there, there's one there. There's one there and one over there. So it's a lot of boundaries. In fact, there's a total of 1, 2, 3, 4, 5 line segments. Because there's 5 of them, that means we are going to have 1, 2, 3, 4, 5 different lines of stuff. Luckily, as you'll see, they are pretty similar in terms of what they look like. For instance, this one, first definitely note that this is 2, which means this number is 1. The scaling here is each of these boxes is 0.5. So please make sure you know that that is 1 and that this is 1 and that's 2 and that's 3 and that's 4. Because when I talk about this, I'm going to say the furthest left is 0 and the furthest right is 1. So between 0 and 1 is where x is. So between 0 and 1. Always less thans, sometimes equal. And the next one is just 1 and 2. And then 2 and 3. And then 3 and 4. And 4 and 5. So they all look the same. 0 and 1. 1 and 2. 2 and 3. 3 and 4. 4 and 5. And luckily, they are all exactly the same. They are closed on the left and open on the right. So closed, open, closed, open, closed, open, closed, open, closed, open, closed, open, closed, open. All of them are closed on the left and open on the right. Closed on the left, open on the right. Between 0 and 1, 1 and 2, etc. Also, easy to write the equation of the line because they don't have a slope. The slope is 0. Up and over, right? Doesn't go up at all. So rise over run is just 0 over 1 or 0. No slope means no x, which means it's just going to be a number. This is height is 1. Since the height is 1, the equation is 1. Since this one's height is 2, the equation is 2. 3, 4, 5. Height of 5 means its equation is just 5. There's no slope, just the y-intercept. Because if you were to continue, its y-intercept would be 4. If you continued, then it would be 3, and such on. Okay. Yeah, that's it for the graphing. In terms of domain, it's pretty normal. The farthest left is 0, including. And if you keep going up these stairs, they are all filled in. They're all good. If you were to walk off this, you would be okay. You'd walk off this, you'd be okay. So there's no unions. It's just going to be 0 to the biggest, which is 5. But that's open, so it's a parenthesis. Range is more interesting. You can't do this in interval notation Because if you turn this sideways, like, there's nothing between here. There's nothing between there. There's nothing between any of those. So you can't do an interval because it's not everything in between. Instead, you have to do set notation. And the easiest way to do that is just do braces and list the numbers 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like so. And that would be the range. The next page is just practice for you guys. As you can see, just want you to do that. If you want to check your answers, the answer key is online. There's this to do as well, but I hope that helps. And I'll see you all later. Have a good day. Have a good weekend.